Fundamental ideas of geometry, there are three things that you have to understand how they work. They are points, lines, and planes. Now, you've already done things with those in algebra when you're graphing a line, right? You're using a piece of paper. That's like a plane because it's a flat sheet, right? You plotted points on a grid, and then you connected them with a line. Those fundamental understandings are what make the basis of geometry. Now, before we get too far into this, let me explain that there's not just one kind of geometry. The geometry that you study is sometimes called Euclidean geometry or planar geometry. It's named for a man named Euclid, who did his studying in Egypt, primarily in Alexandria, a long time ago. And he had several ideas about things. Since then, there have been several other geometries. For example, there's a geometry where instead of a plane being a flat, like a piece of paper, it's like the outside of a ball. And you're like, why does it matter? Well, it changes everything. If you draw lines on a ball, it's different than drawing lines on a piece of paper, right? They don't look the same, but they're both lines for that kind of geometry. Now, the kind that we do works great in localized areas because the Earth is basically flat in that area, right? Like this floor. The floor is flat, okay? So it works that our planes are flat and that our lines are straight. Whereas when you're doing this on a ball, it's called spherical geometry. And by the way, it's what makes global positioning work. You have to understand spherical geometry to understand how global positioning works. Everything changes now. A plane's no longer flat, it's curved. And lines are no longer straight. They're curved also because they have to follow the plane. Points are the same, but everything else is different. Okay? So what's going to happen is we're going to have a few basic assumptions about things for this geometry class, and then everything else is going to be built up from there. Okay? So let's graph a line. We'll do some more graphing later. We're not going to do a ton of graphing in this class. We'll do some. We'll do one unit where we do a whole bunch of kind of review of graphing from Algebra 1. But for today, we're just going to do some basic things. So we want to graph a line with the equation y equals negative 2/5 x plus 4. So I'll take a volunteer. Someone want to tell me just how to start. You don't tell me the whole thing. Just tell me how to start to graph that line. What do I do first? Yes, sir.
Put a dot at 0 x, y, 4.
Yep. Put a dot at x is 0, y is 4. Someone else? Tell me what that is called.
Well, that's the y-axis, or the y-intercept.
Yeah, the y-intercept. There you go. You got it eventually. This is the y-intercept. This is the point where the line crosses the y-axis. All right, somebody else who hasn't helped us out yet. What will we do next?
You try and find the slope of the line.
Okay, what is the slope of the line? Negative 2/5, okay. So we know the slope of the line. So how does that help us? Go ahead.
You go down to the right 5.
Yep. From this point, if we go down 2 and to the right 5, 1, 2, 3, 4, 5, we get another point. And do we need more points in order to draw that line? No. Now, sometimes when you were doing them in algebra, did you do a whole bunch so you could draw a straight line more easily? Yeah. Okay, but do we need more than 2? No, you just need 2. So, from here, I'm going to cheat and use my straight line tool. If you want to use a ruler, there's always rulers in this room back there on that table. Feel free to use one if you want one. Some people don't care that much about whether their stuff is straight. Some people are very freakily interested in how straight their lines are. So the big ideas of geometry, or the underpinnings of geometry, are right there. Points, lines drawn on a plane. That's it. And everything else comes from this. By the way, a couple of things here. When you're drawing a point, we call that a point, but what I draw is actually more correctly called a dot. Okay? A point actually doesn't have any size. It just has a position. It's infinitely small. Okay? No matter the smallest subatomic particle that you can think of, a point is smaller than that. It just has a place. It doesn't have anything else. And then a line is made up of a whole bunch of points. We'll talk more about this in just a second. Does that bother you? Or are you just thinking about it? Okay, either way is fine. That's just an example of using points and lines. So, a couple of questions. What is the least number of points that you need to plot in order to graph a line? Well, we already talked about this. What was the least? Everybody? 2. Does a line end at any of the points you plotted to help you graph it? Does it end there? No. In fact, the line continues infinitely. Did you ever get points taken off on something when you graphed it because you didn't put arrows on the ends? Most people have done it at some point or another. And is there a limit to the number of points that can be on a line? No. There are an infinite number of points on a line. By the way, before we turn the page, do you know what is the opposite of infinite? Pardon? Finite. Who said it?
Me.
Who's me? You have to wave at me. Yeah, I think I told you guys yesterday, but I'm deaf in one ear, and so when you say something, if I'm not looking at you, I don't know who said it, for the most part, unless you have a very distinctive voice. Okay? Thank you. Yeah, the opposite of infinite is finite. Finite means that it has a limited number. There is a specific value. Infinite means there is no specific value. It keeps going forever. All right. So let's look at this next page. And let me rotate this. So this is a particular way, we will use this sometimes, but not always, that you can write a definition where you've got all the information about a particular term that you could possibly want all in one place. It's handy in that it's all on one page. It kind of, sometimes doesn't fit real well and we can't get it all. So if you ever want to do this while we're taking notes and I don't give you one, I have a stack of them up here. And if you like this, where you're like, I like being able to see everything at once, you can ask me for it. If not, that's fine. Either way is okay with me. So for this particular one, we're going to discuss what a line is. So up here in the top in the middle, we'll write whatever word we're talking about. So this is going to be talking about a line. Notice in the left side it says a definition or a description. As it turns out, we can describe a line, but we're not going to be able to define a line. Now, you might be like, why can't you define it? Well, in any given area of study, you have to start with a few terms that everybody kind of goes, we all agree about those, and then you define things based on those terms that you agree about. Right? Have you ever looked up a word in the dictionary and it leads you to another word that you don't know, which refers you back to the first word? That's called a circular definition. It's not very helpful. You have to have some basis to start with. So this is not going to be a definition. This is going to be a description. Now, what's the number one quality that you noticed about the line? If you were describing it to someone in one word, what would that one word be? It's straight. So a line makes a straight path. Extending infinitely in two opposite directions. So, here's an example. Now I'm going to put a couple of points on here, and with points, we will always name them so that we know which point you're talking about with capital letters. It will always be capital letters, never lowercase letters. Occasionally, and you'll see this in your textbook, there will be a lowercase italicized or script letter near one of the arrows so that you can talk about the line. So for example, like that's a cursive L in case you're curious. We'll talk more about that in just a second. All right, properties of a line. Well, we already said the primary one is that it's straight and that it's infinite. One other thing that's interesting about lines, and this is something that's different in our geometry and spherical geometry, is this. If I draw two lines that cross each other, the word for that is intersect each other. How many different places are they going to intersect? Just one. So if two lines intersect, their intersection is a single point. Intersection is a pretty easy idea. You use it all the time with streets. You can use it for any two groups though. Let's do an example real quick in here. So, This is going to work better if I do guys because I have way more guys in the room. So, all the guys, raise your hand, please. Okay, everyone with brown eyes, raise your hands, please. None of the girls have brown eyes? I was like, I see at least 2 that have brown eyes. All right, so what would the intersection of those 2 groups be? You can put your hands down. What would the intersection of those 2 groups be? It would be guys who have brown eyes. They're part of both different groups. Okay? Here, this point right here, whether there's a dot there or not, there is a point there. Right here, that is part of this line and this line. So it is the intersection. It's part of both groups. Okay? All right. What is this a subset of? Well, it's a subset of a plane. We'll talk more about a plane in a moment. But a plane basically is just a flat surface of any kind. Okay. So for us, we'll just go ahead and put that there. A plane is a flat surface. Now, how are we going to name this? I'm a little bit out of room right here, so I'm going to write this. I'll try and squeeze it in. If I want to talk about this line and let you know, hey, I'm talking about that line right there, there's a couple of ways I can write it. I can say RS, and I can draw a short line above it with arrows on both ends. The order is not important. Doesn't need to be alphabetical, doesn't have to be from left to right. So I could also call that line what else? I could call it line SR. Or, because this has a lowercase italicized letter here near the arrow, I could also call it line, and I have to write out the word L. Any of those is fine. All of those describe this same line. Okay? It's not the same as, and we'll talk about these later, a ray or a segment. I think we'll talk about segments and rays tomorrow. By the way, while I'm talking about tomorrow I will not be here. I have jury duty. Yeah, I know. First week of school. I'm thrilled about it. So what's going to happen is this. You're going to have an assignment tonight. You're going to turn in that assignment on Google Classroom. At about the time class starts, a video is going to drop for you in Google Classroom that you're going to watch independently, and I'm going to go through all the answers to the homework and work out several of them. Okay? Then you will also watch a video that is tomorrow's lesson. So please bring headphones or earbuds or something so that you can watch that. Be sure to bring your computer also so that you can watch. Okay? Any questions about that? I think that, and I don't remember his name, I haven't talked to him enough. Our new athletic director, I think he's going to be the one who's going to be in here for that period because they're having trouble finding subs right now. All right. Let's move on. Let's make this a little smaller so I can fit everything on there. There we go. All right. One other term that we're going to look at today, and this is a term that is new to you. It is a definition. The term is collinear. And before we go on, I know it looks like it ought to be pronounced collinear because it's got two L's. And in English, usually that's the way it would work. But English spelling and pronunciation all have rules that we borrowed from, 5 different languages: French, German, Anglo-Saxon, Latin, some Greek. So spelling in English, you can make rules all you like. Unless you know what language it came from, you really can't tell. I'll tell you a joke about this later if we have time for it. But this is pronounced collinear, and I know it looks like it ought to be collinear, but it's collinear. The definition of collinear, and I guess we should say collinear points. So, a set of points is collinear if a single line can be drawn through all of them. Now remember, for lines, what's the primary quality of a line for this class? It's straight. So they have to be straight lines. Okay. In fact, for this class, you'll never need to say the word straight when you say line. A lot of cases you say straight line to describe what you mean. But for this class, if you say line, it's automatically straight. You never have to say straight line because lines are straight. There's no such thing as an unstraight line for this class. Okay? All right. So, let me give you an example. Let's say I have point A here and point B here and point C here. Could I draw a line that would contain all 3 of those points? Yes. So these are collinear. Down here at the bottom, I'm going to draw 3 more. What about those 3 points? Are they collinear? No. We say that these are non-collinear. Now, be careful when you're looking at a group of points. It depends on how many of them you're looking at. For example here, what if I just said points J and K? Are J and K collinear or non-collinear? They're collinear because I could draw a line through those 2. But if I talk about the set J, K, and L, those are non-collinear because I can't draw a single line through all 3 of them. So that's one of the things that is a property is any, and I do mean any, 2 points are collinear. Any 2 points will always be collinear. Because if you've got 2 points, you can connect them with a straight path. And that's true even if they're not on a flat piece of paper, right? If I have 2 points in the room, one here, one there, can I connect those with a straight path? Yes. So those 2 points are collinear. Even if the line isn't drawn for you yet. Sometimes it will be, sometimes it will not be. There is no abbreviation for collinear, unfortunately. There is no subset for that. There are no relatives. That's why this sheet, sometimes it works really well for things, sometimes not as much. Okay? All right. Let's move on to page 4. All right, so let's plot all these points. I'll give you a moment. See how well you remember. I'll do the first one at 3, 4. Remember, you go in the x direction first, which is left or right, and then in the y direction second, which is up or down. Everybody good? All right, well, let's see if you're good. Or you can check my work. By the way, I make mistakes pretty much every day. Please point them out politely. I'll try to do the same to you. If you make a mistake, I'll point it out politely. Okay? There's just lots of places that you can go wrong when you're doing math problems. I'll never be one of those teachers who says, oh, I was just seeing if you were paying attention. Unless I'm up here with a maniacal grin on my face, where you'll know that I'm up to something, it's just because I was probably thinking about something else. All right. So are my points good? Any problems? Okay. So let's graph line AB and line CD. So line AB looks kind of like this. And line CD looks like this. All right, part C, find the coordinates of the point of intersection from part B. So I just drew these 2 lines. I want the coordinates of this point. Okay, who can tell me the coordinates of this point? It's 1, 2, yeah. So is it possible for line AB and line CD to intersect at an additional point? No. Because we're doing this on a plane. By the way, back to spherical geometry for just a second. If I drew 2 lines on this, and a line on a ball has to go like the longest way around, it can't be like the Arctic Circle or something. If you draw 2 lines on this ball, they're going to intersect in 2 places. every single time. Okay, so imagine, like, you can kind of see it, the equator right there, right? And then if I did another line through the North and South Pole, they're going to intersect in two different places. That's one of the primary differences between spherical geometry and what we study, which is called planar geometry or plane geometry. All right, do all lines intersect? No. And when it talks about the Freyer model, that's that picture that we did for stuff. We already added this onto there. If two lines intersect, their intersection is exactly 1 point. Okay? You're going to be asked sometimes to justify why that's true. You have two choices. You can either say, because if two lines intersect, they intersect at only 1 point, or you can say, because lines are straight, once they intersect, they get further away from each other and will never intersect again. You can describe it, or you can appeal to the rule. Either one is fine. All right. For part E, are A and B collinear? Yes. Why? I tell you what, let me get one at a time. What now?
They make a straight line.
How do they make a straight line? Okay, so one way we can describe this is that A and B can be connected, right? That's the word you used, with a straight line. What were you saying, Mr. Gilland?
It says because all 2 points can be connected.
Okay, yeah, you can also appeal to the rule. Any 2 points will always be collinear. So you could write that instead if you wanted to. Any 2 points are collinear. So it's your choice. You can describe the specific situation or you can appeal to the general rule. Either one is fine for an explanation. By the way, you could have also said on this, well, look, they're both on line AB, right? That would be appealing to the particular situation. All right, let's look at F. Are E and D collinear? Yes. Does it matter that we haven't drawn the line yet? No. So, yes, and probably the easiest thing is to say one of these two. It doesn't matter. You choose. Choose what it is that you would like to say about those. You know, if I connect them, I get line ED, you can say that. If I have 2 points, they'll always be collinear, you can say that. Your choice. Fill it in with whatever you want. All right. Part G. Do lines AB and DE intersect? AB and DE.
No.
Here's AB.
Sorry, yes.
Here's DE. Are they going to intersect?
Yeah.
At some point.
At some point they will, right? So, yes. And it didn't ask you to explain, so you can just write yes. Let's take a look at H. Are points C, D, and B collinear? No, but they ask you to explain this, and wording this can be tricky. I think at least. Anyone want to take a shot? Now that I've said this could be hard, anyone want to take a shot at it? Yes, sir.
Maybe not make a straight line.
Okay, when you say make a line, what do you mean?
Make a straight line.
Yeah, anytime someone says, and a lot of students start there, but when you say make a line, I'm like, are they cooking? What's the deal? How are they making it?
When connected, they do not make a straight line.
Okay, so you could say if we connected all of them with straight paths, it wouldn't just be one line.
No.
You could say it that way. So let's write that one down, and then I think there's another way that may be a little less wordy, but I like the idea. If we connect all of them with straight paths, or all of these with straight paths, there is more than one line. You had an idea in the back? Sorry, I haven't learned names yet. Okay. Anyone have a different way that you think you could say it? Yes.
They cannot be connected with a straight line.
Okay. Let me emphasize the point that you made about A and say with a single line or with one line. Yes. And I think that's a little shorter. These cannot be connected or cannot be, what did you say?
Connect.
Okay. Connected by a single straight line. Or do we need to say straight? Nope. So they cannot be connected by a single line. Good. All right. Then last, are A, B, and F collinear?
Yes.
Yes. Oh, there were two H's on this. You'll find that I make that kind of mistake all the time. Or every now and then you'll have a worksheet and it'll be numbered 1, 2, 3, 4, 7, 9, 12, and you're like, what the heck happened there? It's probably because I mixed two worksheets together and I forgot to go back and fix the numbers. That'll happen sometimes. So let's call this one I. The answer is yes, because they can all be joined by a single line. Any questions about that? Okay, your assignment tonight is going to be a worksheet. Let me just tell you that your assignment tomorrow night will be in the book, so you've got to get that sorted out. If you have difficulty with that, or you want to make sure that you're doing it correctly, you might want to get your computer out in a minute and I can help you with it. I would suggest that you download all of those chapters someplace on your computer. And I personally prefer to open them in something other than Preview. Preview I don't care for. I like Adobe Acrobat or Adobe Acrobat Reader much better. But that's a personal preference and it's up to you. Okay? All right.